Hey, hi guys, welcome to my channel .NET Go, and our today's topic is what is data structure and algorithm. Okay, so before start with this session, let me tell you one thing. Like whenever you guys heard this word called data structure and algorithm, so at that time, don't confused and don't get this whole word, which is referencing to any one particular topic, which is wrong. Okay, so whenever you will heard about data structures and algorithm, that means it is actually two different topics, two completely different topics. One topic is data structure, what is data structure, and parallelly another topic is what is algorithm, right? So now the two topic itself a very big topic, and going further we will cover, or we will deep dive in each topics, and we will learn each and every elements of these topics. Okay, okay, so let us start. So what is data structures? Okay, a data structure is a storage that is used to store or organize data. It is a way of arranging data on a computer so that it can be accessed or updated efficiently. Okay, it is not it is not only used for organizing the data, it is also used for processing, retrieving, and storing data. What are different There are different types of data structures are available. Some are basics and some are advanced type of data structure, okay, that are used in almost every program or software system that is been developed. Okay, so we must have good knowledge about data structure. Okay, so basically we have two types of data structure. One is linear data structure and another one is non-linear data structure. Okay, so now basically it is a high level, okay, definition of what is data structure. Okay, if you want to uh, you know deep dive into it, so then you just have to have this idea that data structure means, if you can imagine, then you can imagine there should be a structure, okay, where you can contain your datas. Okay, so you can implement various structures to contain your data. Okay, so those structure will occupy memory in your computer. Okay, so your computer only the place, your computer only gives you the memory, to create a structure. Okay, that is why it is mentioned here that it is a way of arranging data on a computer. Okay, so the advantage is, you can access, once you store your data, once you contain your data in a data structure and you are arranging your data in your data structure, that means in future whenever you required for your application, you can easily access to those datas, or you can update those datas, even you can insert a new datas also. Okay, and we have basically, here I'm having a diagram. Okay, here you can see that data structure, we have basically two types of data structure. One we called linear data structure, and another we called as non-linear data structure. Okay, so inside linear data structure we have again another two types of data structure. One is static data structure and another one is dynamic data structure. Okay, and these are all the examples. Like array is an example of a static data structure, and queue, stack, linked list, these are all example of dynamic data structure. Then in non-linear data structure we have tree and graph. Okay, so each of them means each of the example are different data structure. Okay, and it all those data structure have their own rules. Okay, to containing or arranging the datas. Okay, those we will learn in going further. Okay, so I will conduct different sessions, or I will prepare different videos for each of them. Okay. Okay, now what is linear data structure? A data structure in which data elements are arranged sequentially or linearly, where each element is attached to its previous and next adjacent elements, is called linear data structure. Also, we have two types of linear data structure: static data structure, dynamic data structure. As we can already, we have see this image, then we can easily understand that yes, linear data structure also have two types of data structure. One is static data structure and another one is dynamic data structure. Okay, now what is static data structure? Static data structure has a fixed memory size. Okay, it is easier to access the elements in a static data structure, for example array. And what is dynamic data structure? In dynamic data structure, the size is not fixed. It can be randomly updated during the runtime, which may be considered efficient. you know uh, Memory complexity, it will increase the memory complexity of the code. Okay, for example queue, stack, and then linked list. We have in C sharp, we have list, those things. So for easy understanding, in practically, if you want to understand, then I have my Visual Studio here. If you can see this comment that I have created one static data structure which is an array. So here I'm using C sharp programming language. Okay, if I just uncomment this particular line. Okay, so in this line, means line number 12, I'm creating one integer array. The name is I. So here I just gave a random name, so I gave the name as I. Okay, so this array is having a dedicated size called 5. That means this particular integer array can have 5 elements only, not more than that. It can have less than 5, but not more than 5. Okay, now when we are declaring, when we are creating this particular integer array, at that time if I don't mention any size, you can see here it will give a red underline. That means it is giving an error. What is the error? Error is array creation must have array size. Okay, so we need to give a size. So here I'm giving 5. The same point I have we have already studied in the slide, that static data structure has a fixed memory size. Okay, and then uh, if you can see in dynamic data structure. Okay, so here I'm having a dynamic data structure. The example is list. Okay, so if I uncomment this particular line, line number 25, then in this line I'm creating a you know list of integer. Okay, I gave it the name as J. Okay, so you can see here I didn't mention any size. Okay, still it is didn't give me any error. Okay, so I just created it without any size, and I the compiler also allowing me to do this. Okay, then if I uncomment this lines. Okay, and this line, suppose for example, and here if I give a breakpoint in this line, and if I run this application, it will come and hit this particular breakpoint. You can see that I have created a list variable J, which the count is showing as 0 because it doesn't have any element. Now I am adding an element to it by calling this function add function, and when I'm step over into it, it has added the element. Now the count, initially the count was 0. If I hover over this one, then you can see the count has increased by 1. Okay, so again, it is adding 2 more elements into it, so that means now the count should be 3. Okay, so the same point which we already have studied in the slide, that in dynamic data structure, the size is not fixed. It can be randomly updating, you know it during the runtime. So the same thing is happening here. Okay, during the runtime, it is actually adding all the elements into it, and it is increasing its size. Okay, so this is dynamic data structure. Okay, but interestingly, okay, if I just continue this one, and okay, if I uncomment this one, this array, and now if I uh, suppose point it, give a breakpoint here, and if I run it again, okay, then you can see that I have gave this array size as 5. That means it should it can able to contain only 5 elements, not more than it. So already I have contain one element in line number 13, that I0 equals to 1. Okay, then if I contain this element, then it will be 2, 3, 4 and 5. Okay, now in I array, all the 5 elements, I gave a size as 5. Now all the 5 you know in all the 5 indexes, we have some elements. Okay, 1 2 3 4 5 here, 1 2 3 4 5. Now this is the 6th element I wanted to add. Okay, but I have gave the size as 5. Now what it will do is, when I'll try to store the 6th element into it, then it will give the runtime error. Okay, it will say that index was outside, and bounds of the array. That means your array is getting overflowed. Okay, so uh, that's it. Okay, so now you can understand what is the difference between static data structure and dynamic data structure. Okay, moving forward, we have non-linear data structure. Now, data structure where data elements are not placed sequentially or linearly are called non-linear data structure. In non-linear data structure, we cannot travel all the elements in a single run only. Okay, okay, now this particular statement, like in a non-linear data structure, we cannot travel all the elements in a single run. Okay, this is the main difference between a linear data structure and a non-linear data structure. Okay, non-linear data structure example is trees and graphs. Okay, now we have two different types of data structure, right? One is linear data structure and another one is non-linear data structure. Now the only difference is, in linear data structure, you can target, or you can travel all the elements by one go. Okay, by one uh, by one run. Okay, by one single run. Okay, uh, that will happen in linear data structure. But when you are using a non-linear data structure like tree or graph, you in that case, you cannot target, or you cannot reach all the elements in a single run. Okay, so if you want to you know understand this in a visual manner. Okay, so here I have opened one paint application. Okay, to you know to make you understand that what is that particular statement means. Okay, for example, the linear data structure have one array. So the array data structure, if you can imagine, then the array data structure will be created like this. Okay, like this. If you give a size called 5, then it will have this five you know spaces to store your data. So 1 2 and 3 4 and 5. Okay, this is your array. Okay, other than that, if you use any list or any stack queue, those also look like this. Okay, some are look like this. Okay, mainly those are look like, look like a pipeline. Either will be on this direction, otherwise on this direction. Okay, but it will be look like a pipe. Okay, more or less. Okay, so what happened when you are using any, a static or sorry, linear data structure, the, at that time suppose if you have stored something here and here and here and here and here also, and you want to, you want to reach every element, okay, in a single run, you can, use a for loop, or you can create a algorithm in such a way where you just have to increase the index id by 1, and you can reach every element. You can come here and you can check what is there. You can come here and you can check what is there. Then you can come again here and you can check what is there, and then you can come again here and you can check what is there, and same for that one also, the last one also. That is why in linear data structure you can, uh, you can reach out all the elements, or all the position in it, uh, and all the datas you are storing, you are containing in it in a single run by a very simple algorithm. Okay, in a single run. But just imagine that what is the example of a non-linear data structure is a tree. For example, the non-linear data structure, yeah, data structure, you are using tree. So just visualize a tree. Okay, I'm not very good at painting, but don't judge me on this. But suppose what a tree looks like, right? A tree looks like always this. Suppose this is a, node, or this is a node, this is one node. Okay, this is one node here, one node here, one node here, one node here, one node, and here. So all these things. Okay, this root. Okay, or whatever you can call it, this root. So a tree always look like this. Okay, so this is suppose a tree. Okay, so this is suppose a tree. Okay, so you are using data structure, non-linear data structure tree. So it will be, you will be the technique that how to implement a tree data structure, how to use, that we will discuss in our later session. But just for visual purposes, your data structure exactly will look like this. Okay, where here you can, you will store a data, here you will store a data, here you will store a data, and here you will store a data, here you will store a data, here you will store a data, here you will store a data. This one will be as data. So suppose you want to uh, find out what is the data inside this one, then you have to travel by this way. You have to reach this place, you have to reach this place, you have to reach this place, and then you can reach this place. You don't have to reach every other places, or you cannot reach every places in a single way, right? Because it is not any, the form is not straight line. This one is a straight line, you can understand, right? So linear data structure have a diagram kind of straight line. So that is why you can reach out to every elements which is stored into it in a single run. But when you are using a non-linear data structure, you cannot uh, reach every element in a single run. Okay, so that is the main I can say difference between a linear data structure and a non-linear data structure. Okay. Okay, now what is algorithm? Okay, now algorithm is a totally different concept. Okay, so the data structure is, if data structure is a, you know uh, suppose if data structure is a house, then the algorithm is the, the path how you can, how you can reach or how you can send some object in your place. Okay, so algorithm is different, data structure is different. Now what is algorithm? Algorithm is a step-by-step procedure which defines a set of instruction to be executed in a certain order to get the desired output. Okay, algorithms are generally created independent of underlying languages. Okay, for example, an algorithm can be implemented in more than one programming language. Okay, and here are a few famous algorithms which is algorithms are mainly used for actually these operations. One is search operation. Okay, if you want to search any particular data from or any set of data from your data structure, you can implement one algorithm for it. You can implement an algorithm for sort operation. Okay, now this sort operation is very important, especially uh, if you are you know if you are giving an interview. Okay, and in so in your technical round, uh, anyone can just ask this question to you that write algorithm, give a scenario like we are having us, for example, he will give a scenario like having a string of array with 26 size, and we have all the alphabets in it, but those alphabets are not in a correct order. Means it will be it is not storing as a b c d, it is storing at suppose z and then a and then c and then m and then v. So you want to sort them all. So what kind of algorithm you will follow and you will write? So this is a very important question, what is a sort algorithm. And then insert operation, you can write a algorithm. Update operation, you can write a algorithm. And for delete operation also you can write a algorithm. So these are all the operations for which you can write a algorithm. Okay, uh, a good algorithm is actually following multiple complexity. For example, time complexity, memory complexity, speed complexity, and other also there. But time complexity, let me tell you, I have multiple videos about time complexity. We have multiple different types of time complexity, so please go and watch those. Okay, if you want to learn what is time complexity and how you can achieve those time complexity when you are writing a complicated algorithm in your uh, program. Okay, so please, as per my suggestion, please go and watch those videos. And then we have memory complexity and speed complexity. Those we will learn in our later session. Okay. Okay, yeah, so that's it from my side in today's video. I hope you have understand what I wanted to convey to you, what is data structure and what is algorithm. Thank you very much for watching this video. Take care.